Welcome student. I am Dear Maji, teach physics for NEET, mains and advanced. Now today I will be discussing some important fiwed diagram. Look at this. This is a wedge and a rod is restricted move in vertical direction. And this is also a wedge and this rod is restricted to move normal to this plane. Okay? And look at this. This is the fixed pulley. Third problem. Look at this is the fixed pulley and these are movable pulley. Okay. So we have to calculate acceleration. We have to calculate acceleration of capital M and acceleration of small m. Okay. Now look at this. Here this is a movable pulley and this is the fixed pulley. Look at this. This is the fixed pulley. Okay. Now we have to calculate acceleration of M, 2m and 3m. Okay. And here look at this. Look at this. These are movable pulley. And if this moves upward with acceleration A and this moves downward with acceleration A, we have to calculate capital A and small a. And look at this. Here M. Look at this. These are movable pulley and these two are fixed pulley. We have to calculate the acceleration of this and this. Okay. Now let's start. First of all, constant relation. We know the acceleration of it along this direction is A. Okay, acceleration of it is along this direction A. So acceleration at this point is also along this direction. And acceleration of this is A, so acceleration of this point is also A. Now we know the acceleration normal to the point of contact of two surfaces are same. Now look at this, acceleration normal to the point of contact. Look at this, this is the point of contact. So actually this line is normal to the point of contact. The component of acceleration of this and this along this direction is same. Now look at this angle theta, this is 90 minus theta, so obviously this is theta. So component of A along this direction is A cos theta. Look at this, if this is theta, so this is 90 minus theta. If this is 90 minus theta, so component of A along this direction, if look at this is the A cos 90 degree minus theta. So this is the A sin theta. Okay. Therefore, this acceleration equal to this acceleration. The component of acceleration of small a and capital A normal to the point of contact is same. Therefore, look at this. This is the This is the A cos theta. This is the A cos theta equal to capital A sin theta. Okay. Therefore, A equal to, look at this, capital A tan theta. Okay. This is the constraint relation. Okay. Now look at this. The forces acting on it. Look at this. The forces acting on it. Look at this. The forces acting on small m. Here, this is the point mg. Okay. And normal force. This is the L. Okay. Now look at this. Look at this. Look at this. This angle 90 minus theta. This angle 90 minus theta. So this is the theta. Now component of n along this direction is n cos theta. Now acceleration of it is along this direction. So look at this, the equation of motion, look at this, mg minus n cos theta, this equal to mass into acceleration. Okay, this equation is equation number 2 and this equation is equation number 1. Okay, now look at this, the fiwed diagram of it. Look at this, the normal force acting by the wedge on the normal force acting by the wedge on it is N. So the force acting by the rod on the wedge is also along this direction. Now component of this N along this direction. Look at this. This is the theta. Okay. This is the theta. This also theta. So this is 90 minus theta. So component of it, this is 9 cos 90 degree minus theta. So this is the N sin theta. Now n sin theta produces acceleration A along this direction. Okay, look at this here, n sin theta equal to mass into acceleration. So here n equals to ma by sin theta. Okay. Now look at this. This equation is equation number 3. Okay. Now put the value of n here. So look at this. This is the mg minus n equals to ma. Look at this ma. This is the cos theta divided by sin theta. Okay. And this is the m small a equal to capital A tan theta. So this is the capital A tan theta. Okay. So we get here mg. Look at this. Mg equal to, look at this. This is the a here m cot theta plus small m tan theta. Okay. Small m tan theta. Therefore, look at this. A equal to, look at this. Here a equal to mg divided by, look at this, m cot theta plus capital M cot theta plus, look at this, small m tan theta. Okay, understand? This is the axis of the wedge. Now if we put the value of a here, we get small a. So acceleration of, look at this, acceleration of small a becomes a equal to, look at this, mg tan theta divided by capital M cot theta plus small m tan theta. Okay, this is answer 1 and this is answer other. Okay, understood? Look at this. Here acceleration of m along this direction a. So acceleration of this point along this direction is capital A, and acceleration of it is a. So acceleration along this direction is small a. Okay. Now we have to calculate acceleration normal to the line of contact of these two. So look at this. The normal to the line of the plane of contact is a. The line normal to the plane of contact is this. Now this angle theta, this also theta, so this is 90 minus theta. The component of a along this line is a cos 90 degree minus theta, so this is the a sin theta. Now these two axes are same. Okay, so a equal, look at this, a equal to capital A sin theta. This is the constraint relation. This is the constraint relation. Now we have to calculate the free body diagram. Now we have to draw the free body diagram of this and this. Now free body diagram of this. Look at this. This is the, okay. Now look at this. The normal force acting along this direction. Now point mg directed along this direction. This is the mg. Now component of mg along this direction is mg cos theta. Okay, and acceleration along this direction a. Okay, look at this. So this is the force mg cos theta, and this is the force L. Now the mg sin theta component does not affect because it is restricted move along this direction. So look at this. Here mg cos theta minus L equal to mass into acceleration m into a. So this becomes m a sin theta. Okay, and this is mg cos theta minus n. Okay, this relation, look at this. This is the relation number 2, and this is the relation number 1. Okay, now look at this, the free body diagram of it. Look at this, the free body diagram of the wedge. Look at this. This is the, look at this. Here component of n on the wedge along this direction. The component of wedge, look at this. This is theta. This also theta. So this is 90 minus theta. So component of this n along this direction is n sin theta. Okay, n cos. Component of this n along this direction is n cos 90 degree minus theta. So this is the n sin theta. Okay, now n sin theta is equal to mass into acceleration. Okay, look at this. M sin theta equal to mass into acceleration. Okay, now look at this. N equal to ma by sin theta. This equation is equation number 3. Okay, this equation is equation number 3. Now look at this. We solve 2 and 3. Now look at this. This is the equation 2 and this is the equation 3. Here look at this. So look at this, mg cos theta minus n, and it is to ma by sin theta equal to, look at this, this is the ma, this is the ma sin theta. Okay, now look at this here, mg cos theta, and this equals to a here m plus small m sin square theta, okay, divided by sin theta. Okay, so look at this here, a becomes, look at this, mg cos theta sin theta divided by m plus small m sin square theta. Okay, now look at this, a equal to mg sin theta cos theta by m plus small m sin square theta. Now look at this, small a equal to, look at this, a sin theta. So here mg, look at this, a equal to mg cos theta into sin square theta divided by capital M plus small m sin square theta. Okay, this is the accretion of small m and this is the accretion of OS capital M. Okay, understood? Look at this, these are movable pulley and this is the fixed pulley. We have to calculate small a and capital A. Suppose capital M moves upward direction. Okay, so look at this, when A moves upward, the decrease of length of this takes place. Now decrease of length in each portion is directly proportional to A. So total decrease of length in this portion directly proportional to 7 into A. So increase of length becomes 7A. So this increase of length is equal to A. So its constant relation, look at this, A equal to 7A. This is the constant relation of this problem. Now look at this is the fiwed diagram. Suppose tension in it is T. So look at this, the free body diagram of small m, here T this direction and mg along this direction. So its equation of motion mg minus T equal to mass into acceleration. Look at this, A is the acceleration. Now so this becomes 7 into m into capital A. This equation is equation number 2. Okay. Now look at this, this is a single string. So tension in each string becomes same. Free body diagram of capital M, you look at this, tension T. So tension here T. Okay. So look at this, here tension T. Here tension T. Here tension T. And here tension T. Okay. So look at this, the total tension acting on it is 70 and mg downward. So look at this is the 70. Look at this, this is the 70 minus mg and this equals to mass into acceleration. This is equation 3. Okay, if we multiply equation 2 by 7, we get 7 mg minus 70 equal to 49 ma. Now adding 2 plus 3, we get 7 mg plus capital M plus 49 m into A. Therefore capital A equals to, look at this, capital A equals to, this is the 7 mg minus capital Mg whole divided by, look at this is the capital M plus 49 small m. Okay, and small a equal to, look at this, small a equal to 7a. So 7 into this is the 7 mg minus capital Mg divided by m plus 49 small m. If capital M equal to small m, now look at this is the 6 into 10 into m divided by 50 into m. So look at this is the 1.2 meter per second square. Therefore A becomes, look at this, A is the 7 times of this, so A becomes 8.4 meter per second square. Okay, understood? Look at this is the fixed pulley and these are the movable pulley. We know that the acceleration of movable pulley is the sum of acceleration of its two ends. Okay, look at this. If this is the movable pulley, this moves upward along this direction, acceleration AP, and acceleration of this end is upward direction a1, acceleration of this is a2 along upward direction. So AP equal to a1 plus a2 by 2, and it is the vector relation. Look at this. Look at this. This moves upward, this moves upward. So action of the pulley becomes a1 plus a2 by 2. Okay. Action of the pulley becomes a1 plus a2 by 2. This formula helps us to find the constraint relation here. Look at this. This is the fifth. Suppose acceleration of it is a along this direction. So acceleration of this point is also in upward direction. Now for a fixed pulley, the acceleration at its two ends is same but opposite direction. That is, if it moves this direction, if acceleration at this point along this direction, acceleration here, this is the downward direction. So acceleration at this point A, so acceleration of this pulley is also A along this direction. Now acceleration of this point is A along this direction. Suppose acceleration at this point is suppose A1. So look at this. Look at this. This is obviously downward. Now look at this. The acceleration of the movable pulley A equal to average acceleration of its two ends. So look at this. This is the A1 minus A divided by 2. Okay. So here look at this. A1 equal to 3A. Now look at this here. So look at this here. Acceleration is 3A along this direction. Acceleration of this point A along this direction. Suppose acceleration at this point is A2. Now look at this. So 3A becomes, look at this. 3A, look at this. Acceleration of this pulley is A1. Now A1 equal to 3A. So 3A equals to A2 minus A divided by 2. So look at this. A2 becomes 7A. Look at this. Here capital A along this direction, A along this direction, and acceleration of pulley along this direction. So look at this. This is the 7A. This equals to A minus A by 2. So A equals to, look at this, 15A. Okay, this is the constraint relation. Okay, and this is equation number 1. Now look at this, the free body diagram of small m. Very simple. Look at this here, mg along this direction and tension T in this direction. So what is the equation of motion? Look at this, acceleration A downward, obviously mg greater than T. So here mg minus T equal to mass into acceleration. This is equation number 2. Okay. Look at this here, tension T. So this is the same string, this is also T. So tension at this point is 2T. Now here 2T, here 2T. So this is the tension 4T. Now this and this same string, so this is also 4T. If this is the 4T, so this tension is the 8T. And this also 8T. Now free body diagram of capital M. Look at this. The free body diagram of capital M. Look at this. This is the capital M. Okay, look at this. This is the 8T. And this is the 4T. Okay, and this is the, look at this is the 2T. Okay, and finally this is the T. Okay, look at this. This is the 8T, this is the 4T, this is the 2T, and this is the T. And mg, look at this, mg vertically downward. This moves up with along this direction A. So look at this is the 8 plus 4, 12, 14, 15. So this is the 15T minus capital Mg equal to mass into acceleration. Okay. Now look at this. Here, if we multiply here by 15, if we multiply this by 15, so look at this. This is the 15. Now, if we multiply equation 2 by 15, so this is the 15 Mg minus 15T, and this equals to 15 and A equal to, look at this, 15A. So this is the 15A. Look at this. Now adding this equation and this equation. Look at this. This is equation 3 and suppose this equation is 4. So equation 3 plus equation 4. This and this cancel out. So this is the 15 Mg minus capital Mg, and this equals to, look at this, this is the m plus 2 to 5 5m into a. Okay, now from this relation we can get a equal to 15 mg minus capital M, 15m minus capital M into g divided by capital M plus 2 to 5m. Okay, understood? Look at this. Suppose this moves with acceleration a1, this moves with acceleration a2, and this moves with acceleration a3. Okay, now we have to calculate a1, a2, a3. Now first of all, constraint relation. Look at this. If acceleration of this point a3 along this direction, so acceleration of this point is a3 also downward direction. Okay, for a fixed pulley, acceleration at its two ends is same and in opposite direction. So look at this, this moves downward, so this point moves upward with acceleration a3. Now here a1 along this direction, so look at this, a1 here is downward direction. Okay, now look at this, this is the movable pulley. The acceleration of movable pulley is sum of acceleration of its two relative, sum of acceleration of its two ends. Now look at this. So a2 equals to, look at this, a2 downward, a1 also downward, a3 upward, so a1 minus a3 by 2. So look at this, this is the 2a2 equal to a1 minus a3. So look at this, this is the 2a2 plus a3 and this equals to a1. This is the constant relation of this problem. Okay, this is the constant relation of this problem. Okay, fiwed diagram of M. Look at this, this is the tension T and acceleration along this direction a1. So here look at this, T equal to mass into acceleration. This equation is equation number 2. Okay, now for mass 2m, look at this, the free body of 2m. Here look at this, T upward, and look at this, there, this is the 2 mg, the downward force 2 mg. Look at this, the free body diagram of 2 mg downward, T and T upward. So look at this, motion is a2 along this direction, so this is the 2 mg minus 2t equal to 2m into a2. So mg minus t equal to m into a2. Okay, now look at this, t equal to ma1. So here mg minus ma1 equal to ma2. So look at this, g minus a1 equal to a2. This relation is relation number 3. Okay, now free body diagram of 3m. Look at this. Here 3mg directed downward. Here 3mg directed downward, T upward. Motion along this direction is downward. So look at this, 3mg minus T equal to 3m into a3. Okay. Now putting the value of T. Here 3mg minus ma1 equal to 3ma3. Now m cancel out. So here 3g, look at this, this is a 3g minus a1 equal to 3a3. Therefore look at this, a3 becomes 3g minus a1 divided by 3. This is the relation number 4. Okay, now putting the value of this relation and this relation in this relation. Okay, now look at this, a2. So 2g minus 2a1, a3, look at this, a3, this is the 3g minus a1 divided by 3 equal to a1. So look at this, this is the 6g minus 6a1 plus 3g minus a1 equal to 3a1. Now 6a1, a1, 3a1, so this is the 10a1 equal to, look at this, 10a1 equals to 9g. Okay, so look at this, A1 equal to 90 by 10. So this is the 9 meter per second square. Okay, now what is the A2? Now A2 becomes, look at this, 10 minus 9. So this is the 1 meter per second square. What is the A3? Look at this, A3 equal to 30 minus 9 divided by 3. So this is the, look at this is the 7 meter per second square. Okay, understood? Look at this, mass M, N, hanging this way. This is the movable pulley, this is the movable pulley, this is the fixed pulley. Okay, look at this. Suppose, look at this, suppose axis of it is downward direction, this is the A1. Axis of it is upward direction, this is the A2. Sorry, this is the axis of it is upward direction is the A2, and this is the axis of upward direction is the A3. Okay, now look at this. First of all, constant motion. Look at this. If this mass moves upward with an axis in A3, so decrease of length here is proportional to A in each string, and decrease of length in this two string is 2 into A2. So total decrease of length is proportional to 2A3 plus 2A2. So look at this, the decrease of length in this string, the sum of decrease of length in this string is equal to increase of length here. So look at this, what here decrease of length is 2A2 plus 2A3 equal to, look at this is the increase of length is equal to A1. So constant relation is A1 equal to 2A2 plus 2A3. Now we have to draw the free body diagram of this mass. So look at this, the free body diagram of this mass, this is the mg and this is the tension T, and it moves downward along this direction A1. So mg minus T equal to mass into acceleration. This is equation number 1. Okay. Now look at this, the free body diagram of this mass. Look at this. This is the mg and this is the tension. Look at this, Tt, 2T, and it moves upward. So 2T equal to, look at this, 2T equal to, look at this, 2T equal 2T minus here 2T minus mg equal to mass into acceleration. So this is it. Okay. And finally, look at this, this is equation number 2. And finally, the mass for this mass, this is the 2T tension upward direction and this is the mg downward direction. Okay, so look at this is the 2T minus mg and this is the ma3. Okay, ma3. Now look at this, now subtract this equation. Now equation 2 and 3. Now from equation 2 and 3, look at this, from 2 and 3, look at this, from 2 and, sorry, this is equation number 1, this is the 3 and this is the 4. Look at this, from equation 3 and 4, look at this, from equation 3 and equation 4, we get, look at this, this cancel out. Look at this, left hand side same, so right hand also same. So A2 equal to A3. If A2 equal to A3, no, so from 1, look at this, 2A2 plus A2 equal to A1. So look at this, A1 equal to 4A2. Okay. Now from equation 2, look at this. So this is the mg minus T equal to m into 4A2. Now 2mg minus 2T equal to 8ma2. Okay. And using these two equations, this equation and this equation, we get, look at this, 2T cancel out. Now 2mg minus mg, this equals to mg, and this is the 8ma2 and this is the ma2. So this is the 9ma2. Therefore A2 equals to g by 9. Okay. If A2 equal to G by 9, look at this. If A2 equal to G by 9, so A1 equal to, look at this, A1 equal to 4G by 9. So look at this, A2 equal to G by 9, A3 equal to G by 9, and here A1 equal to 4G by 9. Understood? I hope this discussion will be beneficial for you. Please like, comment and subscribe my channel. If you are new, please subscribe my channel for further update. And hit the notification bell so that you can't miss a video.